So we're going to do a little bit of quiz prep, and the first types of problems you might see are determining if something's a relation or a function. And I'm going to use a mapping. You definitely can use some other strategies that we've discussed, but remember that a function is defined as, for each x value, there's a unique y value. So basically, an x value cannot repeat, but a y value can. So let's take a look at what a mapping would look like. So if we put the domain in this bubble, that's the x values. We have -1, 0, so -1, 0, 1, and 2. So we can put it in that order. It's a little nicer to do as in order. And then let's put the range values in this bubble. So we got 3, 5, 7, 9. This one's going to be straight up, and nothing will cross here, but when we take a look, we go 1 to 3, 0 to 5 is paired, 1 to 7 is paired, and 2 to 9 are paired. So in this case, every x value has one y value associated with it. So just according to the mapping, this is a function. Okay. Number 2, we'll look at the same thing, draw a mapping. You might be able to tell just by looking at it, or maybe not. We take these values, -2, 0, 4, and 6, and then the y values are 0, -1, -3, and -4. So as we do that, we are pairing these up. And once again, it looks like everything has paired up. So it's a function. Let's take a look at one that is not. Let's look at one that's a relation. So if I gave you this set, 1, 4, 3, 7, 2, 9, and let's say -1, 0, and 1, 5. We look at it as a mapping. I put them in order this time. I'll go -1, 1, 2, and 3. And then in our y values, x values, y values, 4, 7, 9, 0, 5. So 0, 4, 5, 7, 9. And let's pair them up. -1 goes with 0. 1 goes with 4. 1 goes with 5. 2 goes with 9. And 3 is paired up with 7. In this case, we have a problem right here because the x value has two y values. So this is what, according to a mapping, what makes a relation. We can't have two y values for one x value. And that'll look the same way with a vertical line test. So in a problem like this, we're trying to determine if this is direct variation. So direct variation, I'll abbreviate DV, is when you have the form of y equals k times x, where k is the constant of variation. And you can think of that like a slope, because it is the slope. And the other way we can translate this y equals k to x is we can say y over x equals k. Now, in a problem like this, we have y is 2, so I can say y to x, and I can set up as a proportion. So y equals 2, x equals 8, and then I need to find x when y is 7. So I have another y and another x. This statement's true. Y over x equals y over x. So we're using that idea of proportion. So now we can substitute. So the first pair, 2, because that was the y here, and x equals 8. We set that up, and then y is 7, and x is 8. If we do some cross product, which you're familiar with in geometry, 2x equals 8 times 7. And the cross product will give us 2x equals 56. When we divide that by 2, x equals 28. So we have found what x equals. And just to check and see if that makes some sense here, 2 over 8 is really equal to 1/4. That's the constant of variation. 7 over now what we found is 28. If we reduce that, that's 1/4. So yeah, those two fractions are equivalent. But that's what direct variation on a problem like this would look like. So you'll also be given to find the slope-intercept form of an equation, and it might give you something that looks like this: 2x equals 20 minus 5y. So I'll rewrite that, and what we're going to do is we're going to solve that for slope-intercept form. The easiest thing to do might be to just make this y value positive over here. If I add that to that side, since those are unlike terms, we would end up having 2x plus 5y equals 20. Now if it said standard form, we would have it in standard form, because remember, standard form is of the form some coefficient a times x plus coefficient b times y equals c. So it would be in standard form, but we don't want it in standard form, so we're going to keep going. So we're going to put x term minus 2x, and we're just going to rearrange these terms on the equation. Now we have negative 2x to positive 20. And now we're almost in slope-intercept form, but we haven't isolated y. To isolate, we divide. Now we can do y equals, all right, negative 2x over 5 is just going to be negative 2/5 x. Plus 20 over 5. Well, 20 over 5 I know is 4 when I divide it. So now we're in slope-intercept form, meaning we're in y equals mx plus b form. If I asked you to identify the slope, you should be able to tell me 2/5. And when I ask you to identify the intercept, you should say coordinate 0, 4. And that's a type of problem that you'll also see. So what if I told you to find the equation if I gave you the slope and I gave you a point? Well, if I give you a slope and a point, you should be thinking point slope. Is this the only way to do it? No, but it's the best and most efficient way in this case. So y minus y1, so there's y1 and there's x1, so those are our coordinates. And there's m as our slope. So y1 is negative 2. Notice how I'm putting parentheses there just to remind myself, oh, I've got to simplify that. Negative 6 is the slope times the quantity of x minus x1. So I've got another negative, put some double parentheses there. So all I'm going to do now is simplify. Y plus 2 equals negative 6. And I'm going to simplify what's in parentheses, do some order of operations here. X plus 3. And then technically we could say that that's an equation. That would be a point slope equation. But let's take it a little further. Y plus 2 equals negative 6x minus 18 by distribution. Get some like terms together. Negative 18 minus 2 is going to give us negative 20. And now I'm in slope-intercept form, and I can easily tell, okay, then the slope is negative 6, and that's what we said at the beginning. But now we can also tell what the intercept is. The intercept is 0, negative 20. So we know where the y-intercept is. This should be a decent review of some of the lesson, and you should take a look at the answers that are provided for the work on the review guide. These are actual problems that are just like some of the quiz problems. So take a look at these, study them, cover up the work, and try to do the work on your own, and then check it, uncover the work, and check what you've done. And that should be a good way to at least have an understanding of the problems presented here.